Functions. I bet you've heard function somewhere in your life. A function can be something in mathematics, something you have heard in computer, and other daily activities. So, what is a function? I'll tell you. Suppose we have a machine. This can be any machine for now, but let's just generalize it to one machine. A machine is something that does something for us. So, this machine takes something A as input and gives out B as output. So if it has to convert A into B, there should be some process inside this machine that converts A into B. This process which the machine does is termed as a function. The function of a machine is the process by converting input A to output B. Okay, so in maths there are machines like this which we call functions represented by f of x. Now they can be not only f, we can represent it by any letter or variable inside. So g of y, h of k, these are all functions. Okay, this is just how to represent a function. Now I'll tell you the definition of a function. Now as we know, we have learnt relations. What is a relation? For example, I'll give you an example of a relation: 2 2, 2 4, 3 1, 4 4. So here there is a relation of 4 ordered pairs. So as we can see, in the first ordered pair the input is 2, output is 2. Okay, second input is 2 but output changes to 4. So you can think of this like, for example, if this machine was a washing machine, this takes in dirty clothes and gives out clean clothes. Now for example, if the machine corrupts and if we give in dirty clothes and it gives out clean clothes the first time, but the second time when we put in dirty clothes, the second time it gives out even more dirtier clothes. So why is that? That's because we cannot term this as a function. The machine has corrupted, so this may no longer be a function. This is just a relation. A relation is something that processes it, but the output is not constant. So like in this case, where 2 was given and 2 was the output, if we give 2 the second time, 4 was the output. So it's not constant in its output. So this can be termed a relation. Alright. Now I'll give you another relation. R is equal to 2 1, 3 1, 4 2. Here we have another relation with 3 ordered pairs. Here if we give 2 input, we get 1 output. If we give 3 input, we get 1 output. If we get 4 input, we get 2 output. So we can see giving unique inputs gives unique outputs. So we can see even if we put 2 the second time, we'll get 1 as output. But due to repetition, there's no repetition sets, so we don't write the set the second time. So even if you put 2 again, 1 is still the same output. Such relations are called functions. So what can we say? Functions are a special type of relation. Alright. And we can underline on the statement that all functions are relations, but not all relations are functions. Okay. So functions definition by textbook is: a function is a relation between a set of inputs and a set of permissible outputs where each input is related to exactly one output. So each input would have only exactly one output. We cannot have 2 that will make the machine corrupt. This is a perfect machine where wherever you give 2, you get 1, even if it comes the second time, but we do not express it in a set because repetition is not allowed in sets. And one more point, when we represent a function like this, the element x is part of the domain. Alright, domain can be, for in this analogy, domain is our dirty clothes, and f of x as a whole will represent our element in the codomain, and that will be our clean clothes. So if we have a set like this, these are all dirty, that will be our domain. We can have shirt, pant, sock, and we have clean ones of the same garments: shirt, pant, sock. So putting a dirty shirt will give a clean shirt. Putting a dirty pant will give a clean pant. Putting a dirty sock will give a clean sock. So dirty pile would be the domain here for a washing machine, and clean pile would be its codomain. This type of arrow diagram represents a function. This can also be a relation, but not all relations are functions. Let's define a function now. F of x equal to 3 plus x. This would be considered a function. So if we give x as 0, f of 0 would equal to 3 plus 0, which is equal to 3. F of 1 would equal to 3 plus 1, which is equal to 4. F of 2 was equal to 3 plus 2, which is equal to 5. These all are based on this function which we have written in the start. Alright, we have to understand what a real valued function is. A function which has either R or one of its subsets as its range is called a real valued function. So for example, we have a domain. We have a domain 1, 2, 3, 4. This is our domain. And we have a codomain B, where B is R. R means all the real numbers. So B consists of all the real numbers on the number line. A is 1, 2, 3, 4. So a function where we have codomain as R or one of its subsets, that can be R minus so and so set. So R minus any set would be a subset of R. So this can also be its codomain. Any function like this would be termed a real valued function. Okay. And a function where A is also R or a subset of R and B is R or a subset of R, this is called subset of R. This is called a real function. So if range is R or subset of R, it is called a real valued function, and if both A and B, domain and codomain, are real numbers, then we can call it a real function. So if f of x is equal to 3 plus I is the complex number which represents root of minus 1. So this would be not a real function. That would be an imaginary function. So in this chapter we only deal with real valued functions or real functions.